Okay, I asked the question online, um, what's the problem with this graph if I was trying to go from point A to point B, the two red points? What's the problem with Dijkstra? So let's just quickly run through and see what order things are going to happen in. It doesn't matter that these distances are all in integers. Hopefully you'll see quite quickly that there is a problem. These distances are related to the actual physical distance between 2 points. So if we look at them, we've got our starting point A, and we connect it to the 3 adjacent ones. So at the moment we've connected to there for 2, there for 3, there for 1, and there for 1. Now we come through and we start choosing, right, which connection can I make next? Well, the next cheapest one is one of the 2 1s. So this one connects to there for 2, connects there for 3, and that's the end of it. What's the smallest value? So the total value at each node, that's what it's currently showing. And we've completed those 2. So I'm going to tick them off. Cheapest node left is the 1, so I've got 1 plus 2 gives me 3, and I've completed that node. Now I'm going to look at a node where I've got 2s. Right. So I've got 2, 2 plus 1 is 3, 1 connection, that node's been made. This node connection goes to 4, completed. Now I can start looking at my 3s. Well, this 3 connects to there for 4, doesn't help. Done. This 3 connects to there for 4, connects to here for 5. The node's done. Next 3 is that one, connects to that one for 4, doesn't help us, tick it off. And then we come round to this next one, 3 connects to there for 10, and this node is connected. Now, hopefully you'll realise that I've now got to go back and start saying, right, all nodes weighted 4, all weighted 5. It's going to take me quite a while to come and look at this node again. And visually, you can tell this route is probably going to be the cheapest route. And that's the problem with Dijkstra. Dijkstra doesn't care about the direction it's going off in. I'll pause the video, fill in the notes and show the rest of this finished off in a moment. But I'm going to spend a lot of my time working down these little zigzags around the outside, which are not necessarily coming directly towards my goal. And this is what Dijkstra tries to improve. It actually takes some sort of measure to say what's the shortest distance from a point to here. So you'd probably use Pythagoras if you've got a grid system like this. And we'll talk about that on another video. I just want to finish off this Dijkstra running through and showing what positions do things get to. So I'm going to stop it, do a few more nodes, then come back when I'm about to start processing this node, and you'll see how much of the graph has been done before I can even start with this node. Okay, I've just added in blue all the extra nodes that I would have processed. And now at the point where we would have done this node. And this node at this point would turn around and tell me, right, to get down to here, I need to have done 20. So it's the 10 plus there, gives me like 20. And that's the current weight for the 20. Come on, is it in red? So we can't say this is the shortest path yet. Remember, we can only do it when 20 is my cheapest node. So I've got to now keep going round and seeing the other paths and seeing how far I get until I get to 20. I'm going to do that now, and I'm going to do it in, I'll go back to doing it in green now. So I've just done this 10, it's now been done. So I've just done the 10 now. So now I've got to come around, do 11s, 12s, and keep going, and I will stop again when I get to the 20. Okay, I'm now coming towards the end of the graph. Notice I've actually done one here where there's an 18 and it goes nowhere. There are other algorithms that will actually turn around and take into account what's actually called the valence of all nodes. If this is a valence 1, there's no point processing it. because it's never going to get to where I need to. So you wouldn't process dead ends. And that's one of the steps in some algorithms is you prune as you go along. What's the valence of the next node? If the valence is 1 and I'm trying to get there, and that's not my destination, forget about it. So the 18 doesn't go anywhere, get rid of it. 18 down here comes to 20. And now I'm at the point where I've got a 20 here, I've got a 20 here, and I've got a 20 here. Either of these two, the value is going to be bigger than this 20. So I've now found 20 is my minimum root. And the route it came from was the 20 came from the 10. The 10 came from the 7, across the 7. 7 came from that 3, and the 3 the shortest route from there. So we've now shown this is my shortest route. I've got to wiggly it down here. But if you have a look at the amount of work that's been done, there's a lot of time spent working on nodes around here where we're going away, or we're using paths that have gone away from our target. This path probably should have been cut out quite quickly. This path, maybe some of these arcs down this side could have been used. Remember, edges and arcs are the same thing. They're just slightly different terminologies. So that's the problem with Dijkstra's.